Hi everyone, so today we're going to look at lessons 4.4 and 4.5 really quickly. 4.4 is a nice review of 4.3. I know you'll be able to hear the tapping of my Apple Pencil, but hopefully it's not too overwhelming. So one of the things we're going to have to memorize or put on our cue sheet is the quadratic formula. And if you remember, the quadratic formula basically looks at ax squared plus bx plus c equals y. It takes y and it actually sets that equal to 0. Okay, so it's actually solving for the x's, okay, in standard form. So this formula gives us the x values that cause ax squared plus bx plus c to equal 0. So a lesson goal is to use the quadratic formula and to see the 3 cases of roots. So if you remember from grade 10, there are 3 ways in which a parabola can intersect the x-axis. It can either do it twice, like what we see here, or it can do it once if the vertex is on the x-axis, or it can do it 0 times. Okay, so let's have a look. So I am going to write out the quadratic formula here. Okay, it's not a bad idea to write it out. And then I am going to pick off the A, B, and C values that are given to me in my question here. All right, so I have A equals -2, B is -3, C is -5. So I'm going to slap that into this formula. Negative B is 3 plus or minus. Okay, -3 squared, don't forget the brackets, minus 4AC all over 2A, which in this case is -4. And when I work this all out, I'm going to put this in my calculator, and I'm going to get 3 plus or minus the square root of -31 over -4. And as you all know, you can't take the square root of a negative number. So what does that mean in terms of solutions to this equation? Well, because I have a problem here and I can't actually take the square root, I have to say, therefore, no solutions. Please don't leave it blank, because if you write nothing there, I'm not going to be sure that you guys know what the meaning of the square root, the negative square root actually is. So I need to know that you know that it means no solutions. Therefore, you have to just write those words, please. Okay, next one. So I said that the quadratic formula solves the equation ax squared plus bx plus c equals 0. But if you'll notice here, I actually don't have a 0. So what I have to do is make one. X squared minus 10x plus 25 equals 0. Okay, and I'm going to take the quadratic formula again. Okay, but this time I have A is 1, B is -10, and C is positive 25. So let's do it. Negative B is going to be plus 10, square root of 100. Actually, let's do it this way. -10 squared minus 4AC over 2A, which is 2. So I'm going to get 10 equals, now when I put this in my calculator, okay, I'm going to get 100 minus 100, which equals 0. So I get 10 plus or minus the square root of 0. And this isn't meant to be a trick question, but maybe it is a bit confusing. What is the square root of 0? It's just 0, so that part goes away. So in this case, x equals 5 is my solution, and I'll notice that there's only one solution to this. Okay? So last one, I'm going to copy paste this again. All right, so what do we get? We've got a is 2, b is -1, c is -6. So I get x equals -b plus or minus the square root of b squared minus 4ac over 2a, which is 4. When I put this in my calculator now, okay, I get 1 plus, because a negative times a negative is a positive, 1 plus 24 times 2, 1 plus 48, that's 49. So x is 1 plus or minus the square root of 49 over 4. All right, and that simplifies to 7 over 4. So I'm going to actually end up getting two solutions here. One I'm going to call x1. Okay, so x1 is going to be 8 over 4, which ends up just being 2. Okay, and then x2 will be 1 minus 7 over 4, which is -6 over 4, which we can write as -1.5 is fine. Okay, so therefore, two solutions. So we've just had one of each example. Okay, we have, part A is the blue graph, B is the purple graph, and C, actually that's backwards. A is the green graph that has no solutions, B is an example of the purple graph which only has one, and C is an example of the blue graph which has two different x-intercepts. Okay, now what does that mean about sort of the number of solutions that we can have? Well, we can see that it has none, one, or two solutions, but we don't have to actually do all that work to figure this out. If you remember, there's part of the formula called the discriminant, okay, that can help us determine how many solutions we're going to have without doing all that work. So if I look at what I've highlighted under the square root, okay, I can see that my number there will tell me how many x-intercepts I have. So for example, in case 1, where I had a negative under the square root, I had no solutions. When I had 0 under the square root, well, that part just went away and I was left with one solution. And when I had something positive under the square root, I ended up with two solutions. So when I go to check to see how many solutions I have, I don't need to do all the work. All I need to do is just look at b squared minus 4ac. This is the part we call the discriminant, okay? And if b squared minus 4ac is negative, there is no solution, okay? If b squared minus ac is 0, there is one solution. And if it's positive, there are two solutions. I'm going to write that out. Two solutions. So it's our job sometimes, if we're given like partial information, it's our job to find values such that we can get one of these three scenarios. So for example, in the question I'm given here, it says, for what values of k does f of x equal 2x squared plus 4x plus k have one solution? So I don't have to jump right to the quadratic formula. What I have to do, though, is check to see what b squared minus 4ac is, and for one solution, which is this case, I want to make sure that it equals 0. So if I look at this equation, I can see that A is 2, B is 4, and a little bit confusing, but C is K. Okay, that value represents C. So when I put it in this formula, I'm going to get 4 squared minus 4AC, which is 2 and K, and I know that in order for us to have one solution, that part needs to be equal to 0. So I get 16 minus 8K equals 0. 16 equals 8K. And then if I divide both sides by 8, to get rid of the 8 here, I know that my K value has to be 2. So when K is 2, then I know that this quadratic will have one solution. So very similar idea, B squared minus 4AC. So for it to have two solutions, I know that that amount has to be greater than 0. So I'm going to boil right down to 16 minus 8K. It's the same numbers as before, but instead of being equal to 0, I know it has to be greater than 0. So what this means is that 16 has to be greater than 8K. And now if I look at this and I divide both sides by 2, what that means is that 2 has to be greater than K. So for all values of K that are less than 2, I will get 2 solutions. So I could probably do this by, the elimination of the other two cases. But basically, what I'm going to end up left with is 16 minus 8K. Where is that less than 0? Well, that's when 16 is less than 8K or 2 is less than K. Okay, so by the process of elimination, I could have gotten that as well. Okay, one more. The height of a ball is modeled by the function that negative 5t squared plus 6t plus 2, where t represents the time in seconds and h of t represents the height. Will this ball ever reach a height of 7 meters? Well, one thing we could do is find the vertex of this and see if it reaches a height of 7. But basically, I have to put, the way we're going to do it in this one is I'm actually going to substitute in a height of 7. And then I am going to use a quadratic formula to figure out what t values make this work. But of course, if I'm using the quadratic formula, one side has to be 0. Okay, so I'm going to get something like this. And basically, I don't have to go through the whole rigmarole of the quadratic formula. I can just use the discriminant, b squared minus 4ac, because that will tell me if there is a solution to this or not. And that's what I need to know, because if it does reach a height of 7 meters, I will find solutions. But if it doesn't, I might have no solution. So let's have a look. B squared minus 4ac in this case is 6 squared minus 4ac. 36 minus 120 minus 84. And this is negative. Okay, so what that means is there are no solutions to 7 equals negative 5t squared plus 6t plus 2. Which therefore means, the ball will never reach 7 meters high. Okay. I'm going to get started on the next lesson as well. It's really just 2 questions. So let's take a look at it. And I will review lessons 4.4 and 4.5 on Thursday when I see you. Okay, so the goal in this lesson is to use quadratic functions to models to solve problems, but it's also it's also a review of when to use a quadratic formula and when to complete the square. So generally speaking, you use the quadratic formula when you have y equals ax squared plus bx plus c, and you want to find the x ints. Okay. Completing the square, you do this when you start with y equals ax squared plus bx plus c, and you use this when you complete the square when you want to get the vertex. So what you want to do is go from standard form to vertex form. Okay, so let's give it a go with a word problem. Okay, a bus company wants to increase the price of transit tickets. The current price is $2, and the company would like to increase it by 10-cent increments. The revenue function for the bus company is given by r of x is negative 40, x minus 5 squared plus 25,000, where x represents the number of 10-cent increases and Rx represents the revenue. What should the new price of the tickets be if the company wants to make a revenue of $21,000? Okay, so the first part of this is pretty straightforward. I'm going to sub in R. I'm going to sub in 21,000 for R. And now essentially I have to figure out the X values that cause this to work, where X values are, X represents the number of price increments, of 10-cent increments. Okay, so how do I figure this out? Well, one thing I definitely have to do is set one side equal to 0, and that way I can use a quadratic formula, or I can maybe use the zero product property. We'll see. I'm missing a 0 here. 25,000 minus 21,000. Okay, and I've actually given an extra power of 2 here. We don't need this. Okay, so what I'm going to do is expand this. X squared minus 10x plus 25 plus 4,000. All right, 0 is negative 40x squared plus 400x minus 40 times 25 plus 4,000. It ends up being plus 3,000. Okay, so what I want to do is find the zeros of this, because that gives us the two solutions for x in this equation. Okay, and there are a few ways I can do it. I can try using polysolve. Okay, I can factor and use the zero product property, or I can use a quadratic formula. Okay, it's totally up to you. But what I can tell you is I can divide everything here by negative 40. If I divide both sides by negative 40, I get x squared minus 10x minus 75, because 3,000 divided by 40, just going to double check. 3,000 divided by 40 is, yes, 75. So there are a couple things I can do here. I could maybe recognize that 75, negative 75, can be written as negative 15 times 5. Okay, so I could do x minus 15, x plus 5. Okay, and I can see the solutions that way. Or another thing I could do, that's one way. Another way I could do this is using the quadratic formula, negative b plus or minus b squared minus 4ac. over 2a. Okay, and that becomes x equals 100 plus 300. Oops. Okay, divided by 2. So x is 10 plus or minus the square root of 400, which is 20. So x1 equals 15, x2 equals -5. This would be x1 equals 15, x2 equals -5. So either way, I'm going to get 15 and -5. But the question is asking what should the new price be? So I know that the new price is $2 plus a 10% increase for each increment. It increases by 10 cents every time. So if I know that x1 is 15 and x2 is -5, okay, I know this can't be true because we're increasing the price. Okay, so this becomes 2 plus 0.1 times 15, okay, because I want 15 increments of 10 cents. So I'm going to get 2 plus 1.5. The new price is $3.50. Okay. Okay, and let's end there. I can do example 2 together with us as a class. This one has to do with completing the square. Okay, guys, I will see you next class. I will be I'll be in on Thursday.